Hello to everyone. Welcome to another tutorial session of the Applied Electricity course. Are you okay? Please, we are still continuing and we've gotten to a very far place. Are you okay? So if you've not watched the previous video, do try as much as possible to watch them. And today we are going to talk about the superposition, right? In our previous video, we've already talked about the mesh analysis, right? We've also talked about the nodal analysis, right? Nodal analysis. Yes. These are the two things that we've talked about under the complex circuits. Are you okay? And we are left with the superposition. Then we'll talk about the Thevenin and the Norton. So the Thevenin will be a next video and the Norton will be in another video. Are you okay? Then right after that, we just jump into capacitors. So if you are not watching the videos, you are doing yourself more harm than good. Are you okay? Try to watch them. And if you have any question, do try as much as possible to connect with me on the Telegram page. Are you okay? So at the Telegram page, I always respond to people's questions. Any question that you have, once you post it there, I will always respond to your group. Are you okay? So try as much as possible to join the Telegram page. I'll put the link in the description. You get it? We've gotten to a very far place. And today we are going to discuss the superposition theory. So let's move on. Okay, to start with, we need to understand the concept of superposition. Okay, so what is superposition saying? It's stating that in any linear circuit, that's a circuit that is made up of active elements and passive elements. You get it? So in any linear circuit, having multiple independent sources. That is, I can replace this with multiple active sources. Are you okay? Active elements in any of them, right? And I believe you already know active elements. So any linear circuit with multiple active elements. Are you okay? So with that one, he's saying that the response of an element, in other words, the response of any passive elements, you get it, will be equal to the algebraic sum of the responses of that element by considering one active source at a time. One active source at a time. Okay. So I'm trying to break it down for you, but as we move on, you understand. If you don't understand the theorem here, as we move on, you understand. The only thing that you need to take note is that if, let's say, I want to remove any voltage source in the circuit, right? If I want to remove any voltage source in the circuit, like if I have a circuit and I want to remove a voltage source, something like this, right? To remove that voltage source, I make sure that I replace it with a short circuit. Take notes. To remove that voltage source, I replace it with a short circuit. But if I have a current source, and I want to remove it from a circuit, I replace it with an open circuit. So you should take note of this. These are the two key things that you need to know, right? For voltage sources. So voltage sources moves with what? With and a short circuit. Okay. Short circuits. And current sources. Current sources moves with what? An open circuit. So these are the two key things that you need to know. If, let's say, I'm removing elements. So if I have a voltage source, let me draw it once again. A voltage source, and I'm removing it from a circuit, I just replace it with what? A short circuit. I short circuit the path, right? And if I have a current source, I replace it with an open circuit. These are the two key things that you need to know. So it becomes an open circuit. Are you okay? So anytime you are finding a current on an element, you always need to consider the magnitude and direction. The magnitude, right? That's the value of the current. Are you okay? So the magnitude and what? And direction. So these are the two things that you need to consider anytime you are finding the current in any of the elements. Because you see, the statement says that we are finding what? The algebraic sum. Do you get it? And the current direction is very important. It determines the sign, right? Whether it should be negative or positive. So we are going to solve a question. Let's jump straight into a question, and you will get to understand better. So if, let's say, you want to understand the theorem very well, just read it. Reverse the video and read it again. Maybe you are going to get it, but if you solve question, you get the better understanding. Okay, let's look at a simple circuit. Right? Let's look at a very simple circuit. A circuit like this. So we have a voltage source here, plus, minus, right? Then we also have a resistor here. Then we have another resistor here in power connection with a current source. Okay. Then we have another connection here, a resistor and a voltage source. This is a very simple question that you can ever get in your multiple choice questions. So we have 6 volts here, we have 8 ohms here, we have 2 ohms here, then we have 2 amps, right? Then we also have 6 ohms, we also have 8 volts, right? And the question is asking us to find the current flowing through the 8 ohm resistor, I. So the question is asking us to find I. Okay. In superposition, right, we made it clear that we are going to analyze the effects of each active element on the 8 ohm resistor. So if the active sources are acting alone, if each of them is acting alone, what is going to be their effect on the 8 ohm resistor? So with this one, we have how many active elements? We have 3. We have 8 volts, we have 2 amps, and we have 6 volts. So in that case, we are going to get 3 circuits. Okay, we are going to get 3 separate circuits. So the first one is going to be something like this. So I'm going to maintain the 8 volts. Right. I'll maintain the 8 volts here. So here is going to be what? An open circuit. If I'm removing the current source, it's going to be an open circuit. And I have my resistor here. Then I'll also have a short circuit. Right. I'll have a short circuit here. And it will end something like this. So I have my 8 volts here. I have my 6 ohms. And I have my 2 ohms here. And I have 8 ohms here. But my target is to find the current that is flowing through the 8 ohm. So let's say I'll call this one moving this way as I1. You get it? So if I should analyze it, if the 8 ohm is to produce current, it will definitely move this way. Because it's moving that way, that's the reason why I show this direction. That is, it is in line with the direction of the current I. Okay. And the next one, I'm going to remove all the two voltage sources. So once I remove the voltage sources, let me draw it again. So this one, I'm going to remove the voltage sources. So here, I'm removing the 8 volt voltage source. So I'll short circuit it. Okay. I told you that anytime you are removing the voltage source, you short circuit what? That path. So here, I'll maintain the 2 amps current. So I have the current source here, moving this way. Then, I have my resistor here. So I'm removing the 6 ohm. Right, so I'll short circuit the path. Do you get it? So here we have the 6 ohms, we have the 2 ohms, and we have the 8 ohm. Do you get it? Then the next element, so this one, where is the current moving? The current is also moving in the same direction. If it's moving in the same direction, it's always positive. And if it's moving in the opposite direction, it's negative. So this one, you are going to get a positive current. Do you get it? You are going to also get a positive current. But let's look at the last one. We are maintaining the 6 volts battery source. Do you get it? So with that one, I have my resistor here. Then we have a resistor top there. But because this is, how do you call it, a current source, I'm going to do what? Open circuit. That part. So it's going to be an open circuit. An open circuit. Are you okay? So after the open circuit, we have our resistor there. Then we have our voltage source, which I'm not going to take it off. Then we take off the 8 volts battery source. Do you get it? So here we have the 6 volts here, and we have 8 ohms. We have our 2 ohms, and we have our 6 ohms. So with this one, the current is moving this way, which is I3, and this time I3 is moving in the opposite direction of I. We're moving in the opposite direction of I. In that case, the value that we get will be what? Negative. IOG. Yes. Any value that we get, we negate it. So these are the 3 circuits that we are going to analyze. So the question is, if you're able to find I1 and I2 and I3, right? After adding all of them, that is I1 plus I2 minus I3 should give us I. Should be equal to I. Okay, so the algebraic sum of the currents, that is I1, I2, I3, should be equal to the main current. So the I1 is determined by what? By the 8 volt battery. So we want to analyze how much current, right? How much current is the 8 volts contributing towards to the current that is flowing to the 8 ohm resistor. And you also want to know the power of what? Of the 2 amps. What the 2 amps is contributing towards the I, that is the current flowing to the 8 ohm resistor. Then we also analyze what is the impact of the 6 volts battery on the 8 ohm resistor. You get it? So that's it. And after knowing the impacts, we just add them to get what? Our I. You see how simple it is? Very, very simple. So let me label this circuit as circuit A. Right? Circuit B. And circuit C. So let's first solve circuit A. So this is how circuit A look like. So I have, let me use a different edge. So this is how circuit A look like. I have my plus minus. Then I have 6 ohm, right? And I have 2 ohm. Since it's an open circuit, I can decide not to draw that side at all. 8 ohm. Okay. Because it's an open circuit. So this is how circuit A looks like. So 8 volts. So I'm looking for I1. I'm looking for I1. That's the I1, the current flowing this way. I1. And this is very simple. I need to first find the total resistance. Okay. So what will be the total resistance? Total resistance is simply going to be what? 6 plus 2 plus 8. Because all the resistors are in series. So at the end, I'm going to get what? 16 ohms. Okay. So now, to find I1 is the same as IT. So I1 equal to what? The IT, the total current of this circuit. And this is giving us the voltage over what? Over the resistance. That's the RT. So what's the voltage here? We have 8 volts. 8 volts on what? On 16. Okay. So 8 volts on 16, I can say that my I1 is equal to 8 goes here 1, 8 goes here how many? 2. So at the end, I'm going to get 1 on 2. Okay. So let's analyze it again. I have my 6 ohm, I have my 2 ohm, and I have my 8 ohms. So at the end, it's going to be 6 plus 2, which is 8. 8 plus 8 is 16. And I know that the total resistance, the VT, right, over RT gives the what? The current that is flowing through. Because that is the same as the total current. So the 8 volts divided by what? The total resistance, which is 16, is going to give me half. And we know that it is moving this direction. The current is moving this direction. Please, always take note, add the direction to it, so that you not be confused. Are you okay? So, the direction is very, very, very important. If you get the direction wrong, you are going to get the final answer wrong. Are you okay? So, the direction is moving this way, which makes it positive. Are you okay? So, let's continue. For the other circuit, what do we have? We are going to get the other circuit also look like this. Let me draw it here. It looks like this. We have a short circuit path here. That's circuit B. We have a resistor here. We have another resistor here. And we have a current source, which we didn't take off. Right. Then we have another ohms here. Okay, very good. So we took off those paths too. So we have 6 ohms, we have 2 ohms, and we have 8 ohms. Okay, and this one was 2 amps. So you can see the 6 ohms and the 8 ohms, they are in series. So this circuit can further be reduced. How will it be reduced? It's going to be something like this. I have, let's say, a resistor here, which is what? In parallel with what? The 2 amps current. So 2 amps current here, 2 ohms here. And they are in series, so I'm going to get 14. That is 6. This 6 plus the 8. They are in series, so I'm going to get 14 here. 14 ohms. Are you okay? Something like this. So now, it's easy to find what? It's easy to find the I2. Because you can see that the I2 is prior to what? The 8 ohm resistor. Right? So this current, when it gets here, some branches to this path and another one to flows here. So in that case, the 2 amps and the 14 amps, they are parallel. So to find the I2 is simply going to be what? The opposite resistor over what? The sum of the 2 resistors, which is 2 plus 14 times the total current, which is 2. Please, if you are confused with the current division, just watch the video, my previous videos, right? Once you watch the previous videos, you understand. I made a video on the current division. So if you've not watched that video, try as much as possible to watch it. I've made a proof on it, right? I've made a proof on the current division, how we had those formulas. So try as much as possible to watch that video and you understand current division. If you don't understand current division, this one will be quite difficult for you. Okay, so let's continue. I2 is going to be what? 2 times 2, which is 4. Let me add this straight away. 2 times 2 is 4. All on what? On 16. And this gives 2 plus 14 is 16. So this is going to give us 1 on 4, right? And the current is moving in what direction? In the forward direction, like we saw. Okay, so we're left with the last one. The last one is more like we took this voltage source off and we have a resistor here which is 6, right? 6 ohms. And we took the current source off, right? So we are left with just the 2 ohm resistor. The current source was off because it's an open circuit. And because an open circuit, there is no path down there. So we have this one towards 8, I guess. Okay, 8 ohms. So we have 8 ohms there. Then we have our 6 volt battery, which is positive, negative. So 6 volts. Equally, we can find the total resistance, right? Our target is to find the current. The current moving this way, right? Which is I3, right? So at this point, we need to find what? RT. And RT is simply going to be 6 plus 2 plus 8. Since all the resistors are in series. So 6 plus 2 plus 8 making 16 ohms. Right. So at the end, I'm going to say that I3 is equal to the IT. Let me say IT is flowing this way. Since they are in series, they are equal. So what do we have? VT on what? On RT. And this is simply going to be what? 6 on 16. 3 goes here, 2 goes here, 3, 2 goes down there, 8. So 3, 2 goes here, 8. So at the end, I have 8 on 3 on 8. And where is the current moving? The current is moving this way. Okay. So let's deduce the current. We knew that I1 is what? Half, but it's moving this way. I1 was moving this way. And we have what? Half. So I1 was equal to what? 1 on 2. Then I2 was equal to what? 1 on 4. So 1 on 4. And I3 is giving us 3 on 8. So at the end, we have this current was moving this way and this is moving that way. So you see, with this, we can say that the I1 is positive because it's moving in that direction. Any current that is moving in the direction which was initially given should be considered as positive. So the direction which was given was moving towards this path. It was moving towards this path. So any current that moves on that path should be considered as positive, and any current that opposes it will be negative. So that current was opposing it. So at the end, if I want to find I is simply going to be what? I1 plus I2 minus what? I3. Right? And this gives 1 on 2 plus 1 on 4 minus 3 on 8. So at the end, I need to find the equivalent fraction for all of them. Like 4. So I'm going to get 4 on 8 plus, I'll multiply the numerator by 2 and the denominator by 2. So I'm going to get plus 2 on what? On 8. Right? Minus 3 on 8. So at the end, what do I get? I'm going to get 6 minus 3 on 8. And this gives 3 on 8. What's 3 on 8? 3 on 8 should basically be, I'm coming, hold on. So, sorry, I was taking my calculator. Okay. So, what's going to be 3 on 8? So 3 on 8 is basically going to be what? 3 on 8 will be, so I is going to be 0.375 amps. Okay. And this is the same as 375 milliamp. That is, if I should move 3 times, it's going to be 3 times 10. Sorry, it's going to be 375 times 10 minus 3 amps, and this minus 3 gives the milli. So at the end, we can say that the current that is passing through what? The 8 ohm resistor is 375 milliamp. Are you okay? Please, if you don't understand, reverse again and watch again. Do you get it? So that you get the understanding. I'm going to solve another question. Let me solve another question, so that you get a better understanding. Okay, so the question I'm going to solve is also quite simple. Very, very simple. Okay, so we are going to solve our previous question. The question that we solved during the nodal analysis. Let's see. I have this one was moving upwards. It was a current source, and here was 3 amps. Sorry. So we had 3 amps here. 3 amps here, right? Then we had another resistor here, which was, let's say, 10 ohm. Sorry. Then we had a resistor up here, coupled with what? A voltage source. That is plus and minus. Right? And this is 20 ohms and 12 volts. Then we also had a 40 ohm here, which was coupled towards a 16 volts. You get it? And the question was saying that we should find the current that is flowing through what? Through the 10 ohm resistor. That was I. So our target is to find the current, or possibly the voltage. Once you're able to get the current, you just multiply with 10 to get the voltage. So maybe the question is asking us to what? To find the current flowing through the 10 ohm resistor. So find the currents flowing through flowing through the what? The 10 ohm resistor. So that's the question. So with this, because we have 3 sources, we are going to get 3 circuits. Because we have 3 sources, 3 active sources, we are going to get 3 circuits. The first one, let's remove the current source. Or, okay, let's maintain the current source. Sorry. Let's maintain the current source. So we are maintaining the current source. As we do what? We focus on removing the other sources. So I have my 10 ohm resistor here. Then I have a resistor here, and at this point I'm going to do what? Short circuit the path. So let me short circuit it. This is short circuit. Are you okay? Yes. So I've short circuit that path. Then we also have another resistor, a third resistor over here, and this time too is also what? Short circuited. So we short circuit the path. Yes. So we have 3 amps here. We also have 10 ohms where we are looking for the current direction. So here, if this current should flow, right, it will move downwards when it gets here. So we can call this one as what? I1. So we want to find I1 in this circuit. Okay. And this is 20 ohm, and this is 40 ohms. Yes. So I1 is moving in the same direction of what? Of I. Okay, so let's move on. So the second one, we ignore the 3 ohms, 3 amps current. Okay. So we take that one off. So when you take it off, you are going to get a circuit like this. And we have our 20 ohms, and we are going to maintain the 12 volts. So we will maintain the 12 volt plus minus. Then we take the 16 ohms out. So when we are taking it out, we do what? We short circuit it. So when it's a voltage source, we do short circuit, but when it's a current source, we apply the open circuit. Okay, so here we have our 10 ohms, we have our 20 ohms, and we have our 40 ohm. Okay, and our 12 ohm, 12 volt is also there. So assuming the 12 volt is supposed to produce current, right? When it gets here, it moves upward like this. When it gets to this path, it will be moving downwards. Okay, and that gives us what? I2. So since it's moving in the same direction, it's going to be what? Positive. Then the last one, what do we do? Let me increase the space. So the last one, what do we do? Very good. So we just take the current source off by applying open circuit. Then we have our 10 ohm resistor. Then we have our 20 ohm resistor here. But this time we short circuit it. We take off the 12 volt and short circuit it, or replace it with a short circuit. So then we also have the 40 ohm resistor, right? And this time we are maintaining the voltage which is connected in series with it. So we have plus, minus, and we have the 16 volts. So here we also have the 10 ohm. Sorry. We also have what? The 10 ohm here. We have the 20 ohms. Then we have 40 ohms. Assuming this is supposed to produce current, right? So where will the current be moving to? The current will surely move all the way from here. Some will pass down. It will still move. Then it will come downwards like this. That is I3, right? So we can see that with this, all of them are moving downwards. All the currents are moving downwards. So I1 is moving downwards. I2 is also moving downwards. And I3 is moving downwards. Are you okay? So our target now is to find the current that is flowing through the 10 ohm resistor by the individual active sources. So once we're able to know the impact of the individual active sources, we can just add the results and get the current, the main current that is flowing towards the 10 ohm resistor. So let me call this as circuit A, circuit B, and circuit C. Are you okay? So circuit A, circuit B, circuit C. So let me draw circuit A again. Let me draw circuit A again here. So I have a current source. Then I have a 10 ohm resistor. Then I have the 20 ohms and 40 ohms. So 40 ohms. So you see, my target is to find I1. So I1. Okay. So you see, with this, I can further reduce the circuit. How do I do that? This is 3 amps, sorry. So I have 3 amps moving upwards. Then I have my 10 ohm current. Since that's what I'm focusing on, I don't do any changes to it. Right? Sorry. I want to draw an active source, but it's a lie. Not going to happen. So I have my 10 ohm resistor here. Then what do? I combine the two. I combine these two resistors. Right. So combining the two resistors, I'm going to get a very big resistor here, which is simply going to be what? 20 times 40, all on what? 20 plus 40. That's the resistor at this end. Right. Let me call it, let's say, R1. So R1 is simply going to be what? 20 times what? 40, all on what? 20 plus 40. And this is going to give us 800 on what? On 60. So we cancel this one. 2 goes down 3, and 2 goes here 40. Right. So we have 40 on 3. Right. That is the R1. So in order to find the I1, which is on this path, please, you see, with superposition, current division is very important. Okay. So to find the I1 is going to be the opposite resistance, which was 40 on 3. So 40 on 3, all divided by the sum of the resistors, which are what? 10 plus 40 on 3, right? Times the total current, which is given us what? 3 amps. Yes. So that is the results. Let's see whether you can simplify. 40 on 3, all divided by what? 30 on 10. No, not 30 on. 30 on 3. Very good. 30 on 3 plus 40 on what? On 3 times 3. Do you get it? So at the end, what do you get? You are going to get 40 on 3, all divided by what? 70 on 3 times 3. And this is similar to what? It's similar to finding the reciprocal of this. So 40 on 3 times 3 on 70 times what? Times 3. So this 3 cancels this 3. So at the end of it, or I1 is simply going to be what? It's going to be 40 on 70 times 3, which is the same as 4 on 7 times 3. And this gives 12 on 7. That's the final answer for us, I1. So I1, which is moving downwards. So I1 is moving downwards. I1 is moving downwards, right? And I1 value or magnitude is giving us 12 on what? On 7. Very good. So the next agenda is to what? Is to find the current this voltage is supplying. Are you okay? Yes. So how do we do that? It's very simple. Right? It's very, very simple. Here we can apply source transformation, like we used to say. So here the current is taking off. So let me not add, or let me not include the current. So we have 10 ohm resistor, then 20 ohm resistor in series with 12 volts. So we have 10 ohm, we have 20 ohm in series with what? 12 volts. Then they are all connected to this 6. They are all connected to what? 40. Right. 40 ohm resistor. So here we have the 40 ohm resistor here. 40 ohm resistor. Are you okay? So with this, let me write my 10 ohm here before I forget. And our target is to find the current here, which is same as I2. Right. This is quite easy. You can use different way in executing it. But with me, I'll go in for what? For the source transformation, so that I can apply current division. Okay, that is one of the easiest. So I'll go in for the source transformation. So in that case, I have a 10 ohm resistor here, right? Then I'll get a current source which will be moving upwards in parallel with what? A 20 ohm resistor, right? Before I add my what? My 40 ohms. Please, if you are confused of why these two were in parallel, watch my video. You get it? If you watch my video, you will really understand. Are you okay? So here we have 12 on what? The voltage over the resistance, which is 20. Please, someone might ask, why did we get a current which is parallel towards the resistor? I've talked about the source transformation. So if you are not watching my video, you are doing yourself more harm than good. So watch the video and you understand what is meant by source transformation. One guy asked me questions on it and I was able to respond to him to satisfy him. Are you okay? So please watch the source transformation video and you'll be fine with how the current was parallel to the resistor. Now that we've got this one, I can combine these two, right? And combining these two, what do I get? I'm going to get 40 times 20 all on what? 40 plus 20. And this is going to give us 800 on 60, right? This is almost the same as this one. Okay, so we've already found out one, and we were able to simplify it to get what? To get 40 on 3. Right, so at the end, the RT is going to be what? 40 on 3. Right, so this is the new circuit for it. I'm going to get a current source which is moving upward, and this is giving us 12 on 20. Then I'll get the 10 ohm resistor, right? The 10 ohm resistor, which we assume the current is moving downwards, and that is the I2, right? Then we have our new resistance, which is giving us what? It's giving us, what did we get for that one? We had 40 on 3. So this one is giving us what? 40 on 3. Are you okay? So in that case, if I want to find the I2, which is moving downwards, are you okay? Which is moving downwards, then it means the I2 is going to be what? The opposite resistance, which is 40 on what? On 3, all divided by what? The total resistance, that is 10 plus 40 on 3, right? Times the total current, which is what? 12 on 20. So at the end, what do we get? So I2 is going to be 40 on 3, all on what? 30 on 3 plus 40 on 3 times what? 12 on 20. So what do we get here? We are going to get, let me move to this side. We are going to get the I2, which is moving downwards, as 40 on 3 times, if I simplify this one, I'm going to get 3 on what? On 70, right? Times the 12 on 20. Are you okay? So we should do some cancellation here. The 3 cancels the 3 here. The 20 goes here 1. 20 goes here 2. Yes. So 20 times 2 is going to be what? 40. Yes. So at the end, we also have 2 going here 1, 2 going to this side, 35. What do we get? We get the I2 to be what? To be, so we have 2 goes here 35. So at the end, this one has been cancelled out. So we have 1 on 35 times what? Times 12. And what's the final answer to this? That is 12 divided by 35. So let me give the fraction form. So 12 divided by what? 35. And that gives 12 divided by 35 is the same as 12 on 35. Okay. And this time, the I2, like we said, is moving what? Downwards. It's moving downwards. So, what is next? Now you are left with the third circuit, that is circuit C. Right? We are done with circuit A. We are done with circuit B. Right? And this is circuit B. So now you are left with what? Circuit C. And we can apply the same source transformation. The current is off. Right? So let me just draw a resistor here. Because the current here is an open circuit. Right? So we have a resistor there. That was the 10 ohm resistor. So we have the 10 ohm resistor here. And the current, let's finish drawing it before we know the value of the current. So we also have the, how do you call it? We have the 20 and 40. By this time, the 12 volt was taken off. So we have 20 here, 20 ohms. And this time, we are taking it off by introducing a short circuit. Right. Then we have the last one, which is 40 ohms. And this 40 ohms is connected to what? A battery. And what is this battery value? The battery value is basically going to be 16 volts. Okay, sure. So we have our 16 volts here. Are you okay? So with this, I can also apply source transformation over here. My target is to find the current I3, right, which is moving downwards. So I can apply source transformation. Then I add the two resistors. So it's going to be something like this. I have my 10 ohm resistor, which I'm not going to change anything out of it. So I3 here. I have my 10 ohm resistor. Then I have 20 ohm resistor here, which we short circuited that path, so it's not needed. Then I apply source transformation. So I have my, the 40 ohm here, which will be parallel to what? A current source, which will be moving upward like this. Something like this. So the value or the voltage value is simply going to be what? 16 on. So let me go there. It's going to be 16 on 40. That is V on R. 16 on what? On 40. That is going to be the current on that path. So what do you do now? You can combine these two resistors, which are in parallel. Okay, when you combine them, what did you get? You don't want to do that combination again. You've already combined them, and we had 40 on 3. So in that case, the new circuit is simply going to be something like this. So we have something here like this. And this is going to be 40 on 3 at the total resistance. So we have 40 on 3 here. Right. No, sorry. We have the 10 ohm resistance here. Then we have 40 on 3 at this point. Then finally we have our current source, which is going to be what? 16 on 40. Yes. So the 16 on 40, like I said, it was obtained from V on R. Right. That is the I. Okay. So at this point, we can find the I3, which is moving downwards. So what is going to be I3? I3 is simply going to be what? The opposite resistance, which is 40 on 3, all divided by the sum of the resistance. 10 plus what? 40 on 3 times the current value, which is 16 on 40. So let me compute with a calculator. So that is I3. Right. So I3 is simply going to be what? Let me use the calculator. This is a complicated one, quite complicated one. So you are going to get 40 on 3. So 40 on 3, all divided by what? All divided by 10 plus 40 on 3. 10 plus 40 on 3 times 16 on 40. So at the end, what do I get? I'm going to get the I to be what? 8 on 35. So that's the I. And that one is also moving what? Downwards. So if you should analyze this, What is I1? I1 equal to, is moving downwards. So I1 was equal to what? 12 on 7. So 12 on 7. I2 was equal to 12 on 35. Okay. So 12 on 35. And I3 is giving us 8 on what? 35. And they are all moving downwards. So they are all positive. Since they are all moving in the direction of the 10 ohm, they are all going to be what? Positive. So in that case, the I, which is the current that is flowing through the 10 ohm resistor, will be I1 plus I2 plus I3. And this is going to give us 12 on 7 plus 12 on 35 plus 8 on what? On 35. Right? We have the 12 on 7, 12 on 35. Then we have the 8 on 35. And what's the final answer for this? So the final answer is simply going to be, we have 12 on 7 plus 12 on 35 right, plus 8 on 35, and that gives 16 on 7, which is the same as what? Which is the same as 2.29 amps. Yeah, I think that's what we had in our previous video. That's what we had. That 2.29 amps. So that's the current that's flowing through what? Through the 10 ohm resistor. To find the voltage flowing through the 10 ohm resistor, it's simply going to be what? The I multiplied by what? The R 10 ohms. And this is simply going to be 2.29 amps. Or 2.29 times what? Times 10. And that gives 22.9 volts. Yes. Okay, so let's solve the last question. Are you okay? Using the superposition. So let's say I have this simple circuit. I have plus minus here. Then I have the 2 ohm resistor here, right? I also have an 8 ohm resistor here. Then I have a 4 ohm resistor here. Then a battery source minus and plus. Yes, something like this. So I have, this is 10 volts and here is 6 volts. And I'm asked to find the current that is flowing through the 8 ohm resistor. Okay, so I can apply superposition here. I can apply, let's say, nodal analysis. Okay, so first of all, there's no need for me to apply nodal analysis. Let me straight away move on to superposition. Are you okay? So if you want to understand nodal analysis, please visit my video. If I apply nodal analysis here, it's going to make the video so long. So use nodal analysis to confirm the answer that I'll get here. Are you okay? So let's move on. To use the superposition, I'm going to get the first circuit to be something like this. So plus minus. Then I have the 2 ohms here. Then I'll get my 8 ohm at this side. Right. Then I'll have the 4 ohm here, which will be in series with the short circuit. Right. I've taken the 6 volt off. So this will be the first circuit for analyzing the current flow. So with this one, if the current should flow, right? It moves here, it will come down. So I1 is going to be what? Positive, right? I1 will be moving down, which will be positive. And what about the next circuit, right? This time we are going to take off the 10-volt supply. So as I take it off, it's going to be something like a short circuit. Are you okay? Let me clean something a little. Let me draw it well. So it's going to be more like a short circuit here. I have a short circuit here, right? It will be short circuited because it's a battery source. Then I have a resistor here, right? Then I have my 8 ohm resistor at that end. Then I have my 4 ohm source. This time I'm going to maintain the 6 ohm power, 6 volts power supply. So we have 4 ohms here, we have 2 ohms, we have 8 ohms. But this time what is happening? See, this time if the current should flow, right, it's going to move this way, so it will move upward. So I2 will be moving opposite towards the 8, the main current, that is the I. So it's going to move in the opposite direction. So this one will be definitely negative. So you need to take note of it. Okay. So now let's call this circuit A and this B. So I'm going to show you a short way of getting the I1. Okay. I'm not going to pass through nodal analysis. I'm going to show you a short technique. So with this, let me redraw it here. I have my 2 ohms here and I have 8 ohms at this end, right? Yes, very good. Then I have my 4 ohms at this end and the short circuit path. Then I have a battery source which is 10 volts. Okay, very good. So something like this is plus minus, right? And I have my 10 volts here. 10 volts here. Okay, so with this, right, if I want to find I1, I can first find what? The VIII. Once I get the VIII, I'll just say that VIII is simply going to be what? Or I1 is, after finding, let me clean this, sorry, let me take it again. After finding my VIII, I'll just say that I1 is equal to VIII on what? On R8 ohms. Okay. So how do I find VIII? I can you see the voltage drop here. The voltage drop at this side is equal to the voltage drop here. Let me call this V2 and V1. V1 is equal to what? V2. They are the same. So if I should combine these two, the voltage will not change. The voltage drop will not change. So I can combine the two of them, the two resistors, to get a new circuit. A circuit like this. I have plus minus 10 volts here, right? And I have the 2 ohm resistor here. Then I get a very big resistor, right? And that one is obtained by saying that it's 4 times what? 8, all on what? 4 plus 8, because it's parallel to each other. So with this one, what do we get? So 32 on what? On 12, right? Yes. So 32 on 12 is simply going to be, so I have 32 on 12. 4 times 8 is 32. Then I have my 4 plus 8, which is 12. We get it. So that one is going to give us, let me turn on my calculator. 4 plus 8. So and then I'm going to get 8 on what? 8 on 3. Very, very tight. So see, once I get the resistance here, right, then I can find the VIII. Right, here is the VIII. V1 is going to be what? The value of that resistor, all divided by what? The sum of the two resistors, which is going to be 2 plus what? 8 on 3 times 10. Please, if you are struggling with voltage division, watch my previous video. And once you watch my previous video, you are going to understand it very well. Right? It's the resistance of where we are finding the voltage drop divided by the total resistance. The total resistance is going to be 2 plus what? 8 on 3. All multiplied by what? By the total voltage. Okay, so let's compute it. So we are going to get 8 on 3 all divided by, what do we have? 2 plus 8 on 3 times, so we have times what? Times 10, and this is going to give us 5.7. Okay, so it's going to be, let me simplify this one. You are going to get 4 on 7 times 10, which is going to be 40 on 7. So that's the voltage drop there. So what's going to be our I1? I1 is simply going to be what? The V on R, on R8 ohms, like we stated. V1 on R8 ohms. Okay. So at the end, what do we get? We are going to get 40 on 7, all divided by what? 8. And this is going to be 40 on 56. That is 40 on what? 40 on 7 times 8. Right. So 7 times 8 gives 56. Okay. So we have 40 on 7 times 8, which is going to give us 5 on 7. So I1 is going to be what? 5 on 7. And that is moving downwards. Right. It's moving downwards. So what about I2? We also redraw the circuit again. Let's redraw that circuit. That's the B circuit, right? So we have 2 ohms here. We have 8 ohms here. Then we have 4 ohms connected to what? Minus plus 6 volts. Okay, so this is how the circuit looks like. That's the B part. We have the 2, 8, 4, 6. Are you okay? So the same applies to the polarity, the same thing. When we analyze it, we saw that it was moving what? Upward. That was I2. So this one too, we can do the same to it. So how do we find it? We can find the total resistance for this. Right? We call this one V2. Right? So that the new circuit is going to be something like this. 2 times 8, all on what? 2 plus 8. Right? In series with what? The 4 ohms. Then in series with the minus here, sorry. Right? So we have minus here and plus there. So in series with the 6 volts. And with this one, we are going to get 16 on what? On 10. Right? So what will be the voltage drop? What will be V2? V2 is going to be that particular resistance, which is 16 on 10, all on what? 4 plus 16 on 10, right? Times 6 volts, or times 6. Please, if you've not watched my voltage division video, watch it so that this one becomes something so simple for you. Are you okay? If you have not watched it, you are going to find it difficult. You are going to ask, why are we getting this here, and why are we getting that there? Why all these things? So please try as much as possible to watch that video, and you are going to really understand what I'm doing here. Those who are struggling to understand are those who have not watched the video on voltage division. So you will not understand why I'm using the 16 on 10 as a numerator, and also making the summation of 4 plus 16 on 10 as 4 plus 16 on 10 as what? As the denominator. So please watch that one. So V2 is going to be, if I should compute, V2 is going to be what? 12 on 7, right? So since I have V2 to be 12 on 7, I can get I2 as what? As the voltage drop over there divided by what? The resistance 8 ohms, right? And that's going to give me 12 on 7 all divided by what? 8. And this will give us 12 on 7 times 8, which is 56. So I2 is going to be what? What will I2 be? That is 12 divided by 56. And that should give us 3 on 14. On 14. Do you get it? So that should give us 3 on 14. So we saw that it's moving what? Upward. That current is also moving what? Upward. So since it is opposite towards the main direction, it's opposite to the main direction, it's going to be what? Negative, like we stated. So I2 is going to be negative. So how do you find it? Let's write them down. We had I1 to be what? To be positive, because it's moving in that direction of the main current, which is 5 on 7, right? 5 on 7. That was the value for I1. I1 was 5 on 7. So 5 on 7. And I2, which is moving upward, so negative, right, is giving us what? As 3 on 14. So this one, the current is moving upwards and the current is moving downwards. So to find I is simply going to be what? I1 minus I2, right? And this is going to give us 5 on 7 minus 3 on what? On 14. And this is going to be 5 times 2 on 7 times 2 minus 3 on what? On 14. So it's going to be 10 on 14. I is simply going to be what? 10 on 14 minus 3 on what? On 14. And this should give us 10 minus 3 on what? On 14. And this ends up to be 7 on 14, which is 1 on 2. So you have 0.5 amps. Right? It's very simple. You don't need to. You can choose to use nodal analysis. You see, when you get to this level, try to use the best way in solving it. Someone can choose to use mesh. Someone can choose to use nodal analysis. And all of them, you need to get the answer. Are you okay? You can choose to use nodal analysis. If you use nodal analysis, you need to get the answer. But if you understand circuit very well, you should use the simplest. So basically, if you get a question, try to see whether you can actually use voltage division or current division. Okay, and with this one, please reverse the video and you understand how I did this. The voltage here are the same. So I can combine it and find the voltage. Once I find the voltage, it's the same as the voltage at this point. So after getting the voltage here, I can apply Ohm's law. Are you okay? So if I combine the voltage here, it doesn't change the voltage value. If I combine these two resistors, Combining these two resistors does not change the voltage value. So once the voltage value is the same, I can apply current division to get the voltage at this point. So getting the voltage at this point, I can just divide it by the resistance to get my current. Is the one of the easiest. So don't struggle using the mesh or the nodal. Are you okay? You use it, you are going to get it right, but you are going to spend more time. So please take notes and understand it very well. If you don't understand, please reread the video. And don't forget to subscribe to my channel. Please, I beg you. I'm pleading with you, right? Subscribe to the channel and click on the notification bell icon to get latest video. The exams is far approaching, so because of that I'll be making more videos. If you have any question, please join the Telegram page. Okay, join the Telegram page and ask your question there. If you are struggling to join, I'll add my WhatsApp link to it. Send me a WhatsApp message. I can see a couple of people are really sending messages. Try to send me the message and I'll respond to you. Are you okay? I'll respond to you as quickly as possible. So please try to join the Telegram page and ask your questions. And don't forget to subscribe to my channel. Subscribe to it. Okay, subscribe to the channel and we'll get more people joining this channel. The channel will be meant for another tutorials in the near future. So try to join it and you really enjoy following me on YouTube. Okay. All the best. Okay. Best wishes to all of you, or best regards. I'll see you in the next video. Bye. Okay.